Hi, everybody. Nice to see you all here. My name is Moti Goldshtein, and I'm the AVP of Product Management for the Allot Smart line of products. And I'll be talking briefly today about 5G and what it has to do with our industry, uh, what is it that we hear about it, what are the global business direction and landscape, and we'll be focused on what are some of the challenges that the mobile network operators are facing and how we as Allot can assist you guys to improve, to overcome those challenges and to have a win-win-win situation so everybody, including end users, could benefit. So let's start briefly about going into the global business directive because we all hear about 5G. We all know that it has new radio and new speeds and so on, but some of the people might say, this is a long-term roadmap, it will not come soon. Well, actually, the reality is a bit different as we see a very strong traction in the market to 5G rollouts. This is a snapshot from the Ookla dashboard. Anybody can go there, look Ookla 5G map, and you see all the cities globally that has 5G, and Ookla is tracking after it. So we see the trend month after month increasing significantly. And I think that one of the drivers to it, which makes it a significant rollout, is when you look at the end user devices and you see that compared to last year when there was a fraction of the handset only with 5G enabled, we see that in 2020, this trend is being pushed to a two-digit percentage, and it will increase in the upcoming years. Clear trend going up, and this is a very critical mass for the 5G, and this reflects why 5G is becoming more and more important. We'll go to the use cases in the next slide to explain what is going on. Now, many of you may be familiar with the IMT triangle discussing the main, I would say, use cases or the main ingredients out of which all the use cases are being built. And this is the eMBB, which is evolved multimedia broadband, the massive machine type communication for connectivity for IoT and industrial IoT, and the ultra reliable low latency communication for mission critical services. Now, many of the consumers and the analysts are focusing on the faster and better throughput, but reality is that the whole picture is comprised of the entire three ingredients combined together to make different type of use cases, from gigabit, from video to smart home, smart building, e-health, smart city, and more use cases that actually, when we look a bit deeper into it, we see that the reality is that it is more complex. It's not just a triangular, but more of a multi-dimensional sphere, I would say, because we see that in the IoT or machine to machine and ultra reliable low latency, we see the vehicular use cases becoming a very growing segment. We hear about smart cars, connected cars, autonomous cars. All of them require high throughput, always on connectivity, and very low latency. Latency is very critical, and 5G has an architecture to support it. We'll touch that soon. We also see another, I would say, dimension, which is, this is why it's dotted here. It's not a use case per se for end users, but this is the cloud ops or the network operation. 5G in general is built under the service-based architecture. Again, we'll touch base that soon. And this architecture enables the operator to move into a much faster pace of introducing use cases and services into the network while lowering their costs. The basic technology that lays beneath it, this is the cloud environment, cloud native, and we see a strong traction towards it, starting from operators like Dish that are now greenfield, all virtualized, Rakuten that announced fully virtualized infrastructure, and this is a big change in the industry. We see it all around. We hear Amazon, we hear Microsoft Azure, and we hear them doing some mergers and acquisition in that. So the entire industry is going to cloud ops, and all of us are moving in that direction. And the main reason for doing so is that this infrastructure, and this is just an example here, enables the infrastructure to be fully virtualized. And when you have such an infrastructure, you can very easily introduce services into the market, because you don't have to go to very cumbersome manual operations and define things and test them. Everything is much more agile and faster. And the agility, the ability to upgrade the network, it's not, you don't need the downtime of hours or months process to roll out the version. You can do it much faster. The upgrade, you can take a service up and down and scale it in, out. Everything is swiftly going on. I'm guessing, in reality, we will not see it, everything in a second, but the pace will be faster, and we see more and more operators adopting this. It's not only a technology, but also a state of mind. I'll touch base that also later on. Another thing that 5G has been introducing to the market, and it's a very important concept, this is the network slicing. This actually enables, it's another, think about it, I look at it as another layer of virtualization in which same infrastructure can be utilized, kind of sliced logically, to enable differential services offering over the same infrastructure, the same hardware, radio, servers, front haul, back haul, and so on. So this enables the MNOs to utilize better their infrastructure, thus increasing the ARPU while sustaining profitability, which is very important concept, obviously. And as I said, adopting cloud operation enables lower cost operation, since you have, continuous integration, continuous deployment, and a fully automated lifecycle management, which helps to operate such a huge network, distributed network, with slicing, with plurality of mobile access and edge computing in a very tight, lean and mean operation. Again, enabling to actually improve profitability. But when we talk about cloud, there's no single cloud. It's not everything is Amazon or Google or Microsoft. Well, I would say not all clouds are created equal. There are different types of clouds, and we see many models in the industry, both in the telecom industry, but also in others. The basic one is the private cloud, in which a CSP or an organization is building their own data center, their own infrastructure. They deploy it on-premises and kind of having their own servers and hardware, but virtualized in the sense that all the vendors working virtually over it. There's also the public cloud, which we are familiar with AWS, Google App Engine, Azure, with different types of business models, but these are computing services that are being provided publicly over the public internet. We also see, for some of the customers or partners we work with, we see the multi-cloud operation, in which they use multiple public cloud. For example, they use Microsoft for that application and Google for the other for several reasons. Be that, point of presence or different application or dual vendor approach, many types of motivations for that, but we see this is the multi-cloud. We also see the hybrid cloud. Some customers want to have some, I would say, critical business application running over the private cloud, while other more, I would say, joint publicly used, they will use the public cloud for that. So this is the hybrid approach. And we also see the multi-hybrid approach in which they have their private cloud and then 2 or 3 public cloud usages. So we see all of that in the market. And the reason I'm emphasizing this has implication over the MNOs and us as vendors to supporting this variety of deployments type, because each one of these deployments has its own requirements and own flavors and own tweaking, and a vendor needs to be able to support it in a good manner and do it efficiently and effectively. Now I will dive a little bit into the main challenges of 5G, and I think the first one is, I would say, rather, wouldn't say old, but previous concept of controlling user plane separation. In 5G, this is inherent. We saw this move in 4G for some of the vendors, some of the operators have done that, not all of them. And this means a complete separation between the control plane and the user plane. And this actually goes to a full-blown when you look at the 5G service-based architecture. And this is a very nice concept. I will touch that just in a second. Those two representatives are actually, both are correct. And we see here the service-based architecture in which we see different network functions. Those could be physical or virtualized. In most cases, they will be virtualized. They are sharing a service bus, so everybody can, if they are authorized, can be registered to a service and get notification, get messages, and interconnect with each other. We also see this view, which is the reference point. This is actually saying which component can connect or is allowed by the standard to connect to a different component, and what is the reference point representation of it. In this case, the SMF to PCF goes through NSEC. In the user plane, we see a reference point in both cases, and you see here the major components of the user plane and the interconnections to the control. So a total separation. Now, this architecture is actually yields a cloud native or a cloud-based deployment and goes beyond the regular NFV, which we are used to in 4G or previous generations. Although some of the operators may start with that but go to cloud later, it really depends on the deployment and rollout strategy of the operators. We see actually a huge variety of those in the market. We've talked briefly about the network slicing, and you see here a representation. It's not really how it's in every case, but just an illustration of how slicing can work. So we see a single infrastructure, and we see the virtual slicing to different tasks. In this case, we say, okay, one slice will be for consumer, the other one for IoT, and the third one for low latency IoT. And we see the different types of traffic flows. For example, low latency IoT may be terminated in the edge to reduce the latency and not go all the way to the core and back. We also see some caching at the edge, caching at the central site. So 5G in general may support tens of edge computing centers in per city, could be thousands per network. And we also see some use cases in which the CSP are hosting application at the edge for other service providers for low latency or latency sensitive application. And this can also save transport costs as we offload traffic to the internet from this point. The MEC, which is either mobile edge computer or multi-access edge computer as we see it now, because it also has inputs that can come from non-3GPP inputs. But there could be a very distributed network. We see also use cases in a three-tier approach, like you have a central, local, and a central, regional, and local entities in the network. So the network can be hierarchical and very much distributed. I'm highlighting this because this comes to the next thing, which is the challenges that MNOs has for 5G. Now, there are many challenges, okay? I'll be humble enough not to touch point on all of these because there are many. This is just an illustration. MNOs has a lot of work to do in order to have a successful, efficient 5G deployment. But we will touch here only 4 of them, okay? And I will focus on the cloud native as an infrastructure, which, as I said, has a significant impact on the overall infrastructure. The increased attack surface, I think this is a paramount aspect of 5G. Okay, so we'll touch base that. We will talk about quality of experience. Now, all of us in the industry have been talking about quality of service for many years. Now, quality of experience is taking it to the next level, adding some, I would say, psychological elements into it, not only measurable, but I will talk a bit more in length, and differential GLAN services, which is also important in 5G as well. So let's start. We are now here, you see, under the infrastructure, talking about cloud native. And as I said, cloud native at the end of the day is a disruptive technological force. It sweeps through the industry, and carriers and enterprise networks are all into it. So the cloud native is really at the heart of the infrastructure for 5G. And it offers, as I said, many benefits as, you know, faster time to market, release pace of services, and updates to the infrastructure. The management is easier, and it possesses the power to have the ability for more reliable system while reducing both CapEx and OpEx, because you can reuse the same hardware, offload, you can close unnecessary services, open new ones using the same compute power, and reduce the OpEx as the management is more automated. But it is a technological challenge to mobile network operators. It's a totally new networking infrastructure. Everything works differently, okay? All the intercommunication between the different functions is not as we used to non-traditional networking with IP. Let's say, at the end of the day, there are IP addresses, but it works differently. There are no static IPs, for example. The routing protocols and so on. It's a huge change. This imposed a new set of requirements from the equipment vendor, from the software vendor, from everybody actually. But it's also a new state of mind on how we operate, how we deploy things to the field, how we deploy our services, how we develop, and the interconnection between the vendors and the operators. And I will go into it soon when we talk about how we resolve it. So this is problem number 1, which I think is understood. The second problem has to do with the increased attack service that 5G deployments employ over the network. As I said, it's a distributed network with a huge amount of devices. We see those IoT devices, and the expectation is to have tens and hundreds of millions of those devices going either through a radio access or fixed wireless access to 5G. Everything is expected to be 5G. Huge amount of devices, and not all of them would be protected. Now think about yourself. How often do you upgrade the air conditioning sensor firmware and keep it up to date? Not all of us doing that. The service attack may also be increased as we see a distributed architecture with many inputs to the network. So both the infrastructure and the service may be jeopardized. And if we look at it, the color codes here may help. Subscribers may generate attacks, either DDoS attacks or hackers, and many types of possible attacks. We can see the service to be attacked either from the core or from the MAC, and the infrastructure may be attacked. Just, think about it, that the vulnerability of devices and the massive amount of them, even if each device is doing a very small amount of traffic, because these are very small low processing power, but plurality of them may cause a DDoS attack on your infrastructure, either the MAC or even go all the way to the core. Also, CNC attacks may be generated, and we already saw evidence for that coming from the internet, coordinating attack for that. But also the UEs, which are now able to create hundreds of megabits or going up to gigabit from each one, such an attack may be very, very disruptive to the network. It could have catastrophic effects, and especially to the MAC, since those nodes of the network are usually with low traffic density, so they are built to, let's say, 10, 20, 40, 50 gigabit of traffic, and a coordinated effect, or even a few amount of users during an attack can have a catastrophic effect on the network. So we see a lot of points that can cause malicious attack, malware, DDoS, bots, all across, okay? But don't be too terrified, because we will present soon some of the solutions for that, just going through problems. The third item I want to touch base now has to do with the quality of experience, okay? How do we prioritize the right traffic at the right time? So when we talk in general about quality of experience, it's very similar. Us in the industry, we are familiar with the MOS that used to have for voice. It's a kind of roughly subjective score that depicts the subscriber quality of experience. Now, it may be very complex mathematical function, and we see that it has to do many parameters inside, but at the end of the day, us as users of the network, we know what it is. We know that when we see a video, we are less concerned about the packet drop per se, but we are very much concerned if we have stalls in the video. Okay, so when we browse, we want to click the site and have the initial page popping up very fast. This makes us very happy. We are less concerned, for example, if the last rollout of the page is being uploaded now, or if we are doing a background download of a new software upgrade or security upgrade, that it will be very fast. We are less concerned with it, usually overnight. So what I'm trying to say here is that in order to have a good quality of experience, one needs to be able not only to provide the right throughput and not truncate it, but to keep it under different types of events in the network, being able to identify them and then to provide what the end user needs. And the end user may be a person, but it may be also a device. For example, if this device is very sensitive to jitter or delay, then you need to be able to provide to this device the right service it needs. Now, you say, hey, but this is what I have slicing for. Well, unfortunately, slicing alone will not suffice because there is so much amount of slices you can support in a network. You cannot have thousands of slices going into the network, but only a few of them. So slicing is a very good idea, but it needs to be combined with a system that enables to maintain the quality of experience, to keep it so that the end user will be happy and satisfied. The last item I want to touch base now has to do with the GI LAN services. We are familiar with it, or even from the 4G, which many operators need to have services in line with traffic, but they are not terminated in the flow, like DDoS, TCP optimization, anti-botnet, and so on. So you need to create a kind of a chain outside of the core, okay, and to be able to define how the chain flows. So, as I said, many challenges, but let's see how can Allot help to overcome these challenges. So, first of all, talking about cloud natives, look, the industry has been going through this, and so did we, from appliance to virtualization to NFV and now cloud native. So we are not new to those technologies. We are working hand in hand with our customers because it has to do, we also are learning, and we are actually now participating with multiple deployments of cloud native in the market with our customers. So we are very thrilled to do that. And we are actually building our DevOps and CI/CD approach together with our customers, as you can see here as an example of what we're doing with our customers, with continuous integration in our premises, hand in hand with continuous deployment, for the CSPs, or in this case over Kubernetes, which really helps us to streamline the operation. So we are now in this journey. We started it a while ago, and we are learning and improving, but also working in the field with our customers already deploying, and this gives us a huge advantage, and we'll be able to assist you to deploy a cloud native infrastructure or to deploy our services over cloud native infrastructure. Now, we also talked about security and how can we secure our user plane, okay, to have all the lanes running smoothly with all this traffic going on. So we have multiple services you can deploy, starting from the Allot DDoS Secure that provides protection against DDoS attacks and both mitigation and isolation. We have our IoT Secure and Network Secure that enables to protect the end nodes and the core from attacks. And all of this is being powered by our Allot Smart DPI that enables to maintain the quality of experience throughout attack. So even if you are facing an attack now, we'll be able to maintain the critical services, again, to a certain extent, of course. But while we mitigate the attack, we'll maintain the important application and the quality of experience throughout the network, providing also web filtering for regulatory compliance, and a set of tools to assure that the revenue of your system being maintained from different types of aspects, from policy, control, charging, and so on, but this is a subject for a different, maybe a webinar over that. When we look at the overall architecture, we have a truly inline and scalable virtualized protection for your network that enables the operator to deploy it in the field very easily, both at the core user plane protection and at the MAC. So this kind of protection enables you to have a full suite of protection that gains its power from the combination of those three elements. First of all, we have a tier 1 carrier grade platform that is being field proven with 100% inline inspection and fully integrated. It has a user slice cell awareness, assuring the SLA in the cell. And it is, as I said, quality of experience aware and with congestion management mechanism. And it provides you a best of breed protection with machine learning and artificial intelligence capabilities, inline DDoS mitigation and regulatory compliance, and we actually getting the strength of it from the combination of it all. And as I said earlier, quality of experience is very important, and Allot is being able to provide you all with a very robust quality of experience. First of all, visibility from different level of the network, but also assurance that goes beyond a standard user plane function with analysis per application, enforcement for QoE, affecting policies, and machine learning, artificial intelligence empowered to mitigate the increasing trend of encrypted traffic. So we touch base the first three, and we are left with the fourth one, rushing up as I'm running out of time here. And the GI LAN services is also a very important key concept, which I like to highlight specifically for service function chaining. When you want to provide differential service to application based on their type, location, time of day, for example, if you want to have some subscriber that will include URL filtering and the other that will include or exclude TCP optimization, you'll need to be able to construct a chain and then to determine what would be the path. So the Allot service gateway has this capability to steer traffic, and as you can see here in this illustration, we see two paths. So we see now policy 1 going on through this chain, and then policy, see the packets flowing in. So regular customers go directly, and the other one go to this service function chaining. And the second customer has a different chain going on. So this enables you as an operator to use Allot to provide different types of services in your GI LAN. So going into the summary, I'd like to try to grasp all the things we've said here regarding 5G and Allot's vision in regard to it. So 5G is gaining momentum in the market, promising new use cases for MNOs, enabling them to increase their output, gaining more profitability and more revenues coming in, more business cases into the market. The service-based architecture in general is designed here to have a swift time to market, new pace of introducing services to the market, but on the other hand, it possesses a challenge, a technological challenge, a deployment challenge over the market. And Allot is here to assist you with some of those challenges. We are currently supporting multiple tier 1 operators globally. We are doing this journey with them. We are learning, we are improving, and we already have a very significant set of capabilities to assist you to deploy in a cloud-native environment, to provide a robust user plane protection to mitigate the increased attack surface that 5G imposes. So you will have a safer and more reliable mobile network infrastructure, guaranteeing quality of experience to your customers through event-driven and application-aware quality of experience, and also providing a variety of GI-LAN services, differential services to your customers. So, thank you everybody for attending this webinar. I hope you learned one or two things and enjoyed the time, and I hope it will be valuable for the rest of your journey. Thank you very much.